Okay, welcome to 2020 question B3. Okay, perspective drawn. So the image on the right shows a monument to the deceased, members of the defence forces. A plan elevation, okay, of a pyramid based on the image of the right. A pictorial view of the structure is also shown. Part A, draw a given plan and make a perspective drawing of the structure given the following. The spectator is 3.3 metres from corner A. Picture plane touches corner A. So there's the picture plane there. So there. Alright, and the horizon line is 3 metres above the ground line. Scale is 1 to 30. Okay, so we have to convert, okay, all dimensions into millimetres. So 0.9 metres is 900 divided by 30, okay, is equal to 30. That's what we have to do with all our dimensions. Careful not to mix up 3.6 metres and 3.36 metres. Those distances, 0.42 metres, 420 divided by 30 will be 14. Okay, and then the 0.21, that'd be 7 millimetres. So I'm going to start drawing out the plan view of it there. So base of the square, 112. Okay, easy to mix it up with 120. Now, we can join the diagonals lightly. We're going to plot 3 14s along the bottom, and then there's going to be a 7. So 3 14s and then a 7. So 14, 28, 42. Okay, a 49. Then from the other side, okay, 14, 28, 42. There we go. Now, can join heavy line up till I hit the diagonal here. And same here on the opposite side. Then marked in, okay, you know then I'm going across, and then I'm going round. So you don't need me to do that. I'm going to pause and complete it. That marked in, and don't forget, okay, point C, the chimney, okay, in plan the flag, Alright, the flag is located at position 3 in plan, so 45 degrees up at 0.6 meters, 600 mil, which will be 20. So that's easily forgotten, that. So that's the position of the flagpole in plan. Okay, now, so the spectator is 3.3 meters from corner A at position down along S. So 3.3 meters, 3,300 millimeters down a 60 degree line divided by 30. Okay, is going to be 110. So I'm going to mark S there. Okay, and I'm going to join the outermost points. I can join S to the two outermost corners, and then I can bisect the angle. So I can bisect this angle. And then my picture plane is going to be at 90 degrees to there. So I can draw my picture plane through there. And then from S, I'm going to go parallel to a set of lines. Okay, here. And then this set, I'm going to go parallel to find the vanishing points. So here's VP2 on the picture plane. And here's VP. There's VP1 on the picture plane. So then the horizon line, okay, is going to be parallel to the edge view of the picture plane. It's going to be parallel to the edge view of the picture plane. And the distance between the horizon line and the ground line is 3 meters. So scale 1:30. That's going to be 100. So then my ground line, okay, it's there. Parallel to the horizon line. Now, okay, for perspective, join all the points on plan to the spectator, and where to pierce the picture plane, we're going to bring them down perpendicular to the picture plane. So you don't have to join every point, just the necessary points. And you learn that these points, okay, parallel lines will go to their respective vanishing points. So I'm going to join all the corners to S, and when there's them joined together. I could have, right, so I joined those points to the spectator. I could have joined these instead, but the angle is a little bit narrow, so it's easy to get them wrong, so that's why I chose the wide one. Right, I'm going to drop corner A down, okay, perpendicular to the picture plane, right, and then I'm going to drop my vanishing points down as well. That's corner A. So I'm going to drop my vanishing points down onto my horizon line. Gel. GL. Now, I can join corner A to the horizon line. Or sorry, not to the horizon line, to VP1 on the horizon line. There's VP2 on the horizon line. So I can join A to VP1 and A to VP2. Now where does the pyramid stop? Well, here's the end point of it. It's going to drop that down perpendicular to the picture plane. And then the same here, the outermost corner, when joined to S, where it hits the picture plane, I bring down perpendicular to the picture plane. Notice the way, didn't have to join each line totally to the spectator. You could if you wanted it, just saves a bit of speed. Now, I'm going to join a heavy line here, a heavy line here from A. It's the outline of the pyramid. Okay, now, then I can drop these 2 points down for the base of the channel. On the faces, there we go. Same over here. There we go, there. Right, so there, the channel is there. Right, let's get the height of the pyramid. So only true heights can be applied along a point on the picture plane. So I'm going to extend, I'm going to draw a line parallel, okay, to one set of lines in the sheet until they hit the picture plane. And I'm going to go perpendicular to the picture plane. Now I can step the height of the pyramid from the ground line on this line. So the height is 120. So I can step the height of 120 there, and I can join back to VP1. Okay, now, so I can join the apex of my pyramid to S. Go on ahead, do it again. Okay, so we're going to drop down, we're going to join the set apex, okay, where it hits the picture plane. We're dropping that down perpendicular to the picture plane, where it hits the height line. That's the apex of the pyramid. So I can join that to there, join to A, and join the corner there. Right, okay, now the best thing to do now is to be getting the channels on it, okay, to finish the channels. Right, so I need to get a start point on one of the channels there where it hits the edge of the pyramid. If I just get one, I'm going well. If we just get one, I'm going well. So I'm going to take an edge here, or a point there, join to S, where it hits the picture plane. Go down, perpendicular to the picture plane. That's where it is on the pyramid. I picked the wrong one there, I think. So yeah, I was thinking, I knew I picked the wrong one. There we go. And then I can join that to, so I can join this off to VP2, and then this off to VP1. Okay, then heavy line there, heavy line there, heavy line here, now then it's pretty easy then to do, okay, it's pretty easy to do the horizontal lines on the pyramid that are, again, real life sections. So you can bring this one down till it touches the edge of the pyramid. Okay, go from VP2, okay, through that point, then you know you have the same to do on two other points, so that's joined. So I'm going from VP2 through there, and then I have another one to do just there. It's going off to VP1 then. So there's that part of the pyramid. For the last part, okay, the true shape of a flag is located at position 3 in elevation. So when it says the true shape, okay, that means, okay, this has to project as an edge view and plan, and if this surface, the flag, projects as an edge view, then the flagpole projects as a point. Okay, the flag is in the shape of an equilateral triangle. Draw the flag, okay, in perspective views. Use auxiliary vanishing points to determine, okay, the sloping line. Now, okay, we can find the heights, okay, from elevation. These, you can see, okay, you don't even need to draw the elevation. You can see this is 30 millimeters, 0.9, and these, it's safe to assume they're 4 equal parts, because 3,600 divided by 4, is 900, then the scale is every 30 mil. Okay, so 30. So we need to get, okay, this flagpole in the perspective, okay, before we do the flag. Now we will use, okay, a height line to get the flagpole. So look, we're going to go parallel to one set of lines until it hits the picture plane, drop down. When two heights can be applied along a point on the picture plane. So that is 90 millimeters and that is 120 millimeters. And we can join to VP2 because that's where they're going, and join to the spectator, the flagpole to the spectator, and drop down. And then we'll do, okay, then we shall do the sloping lines of the flag, the auxiliary vanishing point. So this is a big question now here. So I'm going to have to extend on my picture plane. So I can bring that down. There's the ground line. So 120 high, okay, 90 and 120. And then, so we're going, and the base, so we're going joining all them to VP2, which is a long question. You need your T-square to be joining these. That's if you have room. Or at least I wouldn't have room on my desk, so not to be drawing them. So I'll actually have to pause. Then I'll have to get a longer ruler. My drawing board is the bigger. So I'm joining VP2. Through to there. One second. Still in the way. 1 sec there. Now, there's 3 heights joined together, or joined back to VP2, and join C back to S. Okay, perpendicular to the picture plane. So here's the flagpole in there. Now, we know it's an equilateral triangle in there. So that's 30. We need to find, okay, well, no, we don't need to find it. We know we need to find the auxiliary vanishing point. So the slope is 30 degrees. And the sloping lines would be using, okay, the vanishing point 2. So I am going to get my set square and go 30 degrees from S to line S to VP2, and then perpendicular to S to VP2. And I'm going to get the height here. And get the height here, step it above and below, okay, which I'm really too tight in room there, so I have an alternative way of going through it, which I'll go through in a minute. So there's an auxiliary vanishing point. Now, I can draw a line, okay, down through the top of the flag there. There's the auxiliary vanishing point. Okay, so I'm drawing a line through there. I don't know where it stops yet. Okay, so how I can figure that out is I'll draw the true shape of the flag up here. So just up underneath C, I'm going to draw the true shape of the flag, or just above C. So 30 millimeters. So it's an equilateral triangle. So here's the apex of the flag. Okay, there's the apex of the flag in plan view. Then likewise, could join the apex to the spectator. Go down perpendicular to the picture plane until it hits that sloping line. So until it hits that sloping line. And then we can construct that in there. There's the flag down from C. There's the height of it. Let's go over there. And there's the question complete. Okay, cheers, thank you, bye bye.